In this lecture, we begin to start learning how to do proofs in predicate logic. We'll start out by introducing a rule that allows us to manipulate sentences involving the universal quantifier. This rule is referred to by your textbook as universal elimination. It is more commonly known as universal instantiation, but we'll go ahead and stick with the term that your textbook uses, universal elimination. The universal elimination rule may be stated as follows. If one has a line containing a sentence with a universal quantifier out front, one may infer a line containing a sentence just like it, except in which the universal quantifier out front has been removed, and each variable which that quantifier ranged over was uniformly replaced by a name. Okay, this statement of the rule is quite a mouthful, but it's pretty easy to see how the rule is applied once you see a few examples. So let's look at some. So let's begin with the following example. So this might be a translation of the argument pattern, all humans are mortal. Therefore, if Socrates is human, then Socrates is mortal. That is, for any x, if x is human, then x is mortal. Therefore, if Socrates is human, then Socrates is mortal. This is clearly a valid argument pattern, and we are now in a position to prove that it is valid using the rules that we now have at our disposal. So we begin by writing down our premise using the rule of premises. The rule of premises is one of the rules that we had at our disposal when we did propositional logic. And we're going to take all the rules that we had at our disposal in propositional logic and import them into predicate logic. So we still have all the rules that we did before, including the rule of premises. Okay, now we apply the rule of universal elimination to line 1. We do that by deleting the quantifier out front. So we delete the for any x out front. Now the variable that the universal quantifier out front, the for any x out front, ranges over is x. So we take each occurrence of x in the original sentence, and we replace that occurrence by the name s. And we're done. We have now proven this sequent. Let's look at another example. So consider this argument sequent. Let's say that L is the predicate loves. Then this says for any x there exists a y such that x loves y. Therefore, let's say that M is the name Martin. Therefore, there exists a y such that Martin loves y. That is, we might interpret this as expressing the argument everyone loves someone, therefore there is someone who Martin loves. This is clearly a valid argument pattern, and we are in a position to prove that it is valid using the rules that we have. So we begin by writing down our premise using the rule of premises. Then we apply universal elimination as follows. We take the for any x out front of the sentence in line 1, and we delete it. And we take each occurrence of the variable that the for any x ranges over, namely all the occurrences of x, and we uniformly replace them with the name m. And that's it, we're done. Now note that I didn't do anything with the variable y. That's because the for any x in the sentence that occurs on line 1 only ranges over x, it does not range over y. So when I apply the rule of universal elimination, I only pay attention to x. I don't do anything with y. Okay, let's look at one final example. So this is how we symbolized the argument all humans are mortal, Socrates is human, therefore Socrates is mortal. That is, for any x, if x is human, then x is mortal. Socrates is human, therefore Socrates is mortal. We are now finally in a position to prove that this argument is valid using our rules. So we begin with writing down our premises using the rule of premises. Now we'll apply the rule of universal elimination to line 1 to get if HS then MS. Okay, now our goal is to get MS, and by examining lines 2 and 3 we note that we are in a position to do that because on line 3 we have a conditional and on line 2 we have the antecedent of that conditional, and we're importing all of the rules that we have from propositional logic into predicate logic, including modus ponens. So we are in a position to apply modus ponens to lines 2 and 3 to get the consequent of the conditional that occurs on line 3, which is MS, and which is what we want. And now we're done. So note that on line 3 we applied the rule of universal elimination to line 1. That was the new rule that we had. But then from there on it was as if we were just working within propositional logic. Okay, so now that we've examined these examples, I'll go ahead and give you a homework assignment that allows you to practice applying the rule of universal elimination before we move on to the next lecture.